Welcome back. This is the Lifting the Fog Conference, applying the scientific method to World Trade Center destruction. The morning session was a pleasure. We had a lot of wonderful speakers, and it's good to see so many of you come back, and it's also good to see so many new faces for the afternoon session. The afternoon session today, starting right now, will be with Dr. Stephen Jones. And at 3:30, there will be a session with Jim Hoffman, and the evening sessions begins at 6:30 with several of the day's speakers, including both Dr. Jones and Mr. Hoffman, as well as Peter Phillips from Project Censored, and others. So please go out. If you don't have a schedule, please go into the hall over here. There are schedules. There's also a donation box, so if you're feeling generous, please feel free. If you've already donated, we thank you graciously. My name is Mickey Huff. I'm an adjunct history instructor. I teach a course on 9/11 at several colleges, and we put this event together over the last 4 months or so because we think it's a really important thing, particularly within the 9/11 movement, to focus on science and the facts, because these things really do matter. And we couldn't have a better speaker today to do it with Professor Jones. I'd like to introduce who's going to actually introduce more about Stephen Jones, and that's Carol Brulé, who's done a large amount of work for the 9/11 Truth Movement. So let's have a round of applause for Carol.
Thanks, Mickey. Well, it's a great honor to introduce Dr. Stephen E. Jones, whose work has been at the heart of many new, compelling documentaries. And he's also received quite a bit of unmerited criticism and has been attacked for his radical challenge to the official 9/11 story, the foundation of the government's draconian policy changes, and the war on terrorism since that day. The first line of imperial defense has always been to shoot the messenger. The Santa Rosa Press-Democrat, in a cover story, placed in its headline, "SSU hosts discredited academic who says U.S. could have planned attack." Well, Dr. Stephen E. Jones is not a discredited academic, although he and the university that he used to work for were under tremendous pressure not to publish his research, particularly his paper, "Why Indeed Did the World Trade Center Buildings Collapse?" He voiced a taboo question, but his academic credentials are not easily dismissible. He is a Mormon, a man of great faith and personal integrity, committed to truth and to serving humanity. He cares deeply about his family, his students, an entire generation that are in danger of being sent abroad to fight in wars. He believes that the country should live up to its ideals and its Constitution. And he used to be a Republican. In 1973, he earned his bachelor's degree in physics, magna cum laude, from Brigham Young University. He received his PhD in physics in 1978 from Vanderbilt University after conducting research at the Stanford Linear Accelerator Center. He did postdoctoral research at Cornell University and the Los Alamos Mason Physics Facility. He conducted research at the Idaho National Engineering Laboratory and G-Idaho, Idaho Falls from 1979 through 1985, where he was senior engineering specialist. He was principal investigator for experimental muon-catalyzed fusion for the U.S. Department of Energy, Division of Advanced Energy Projects. He also collaborated in several other experiments, including experiments at Triumph in Canada, the National High Energy Laboratory, KEK, in Tsukuba, Japan, Rutherford Appleton Laboratory in Oxford, UK, and Kamioka, Japan, and was awarded a Creativity Prize by the Japanese Creativity Society in 1989. He was Associate Director of Brigham Young University Center for Fusion Studies from 1989 through 1994. He did research for fusion in condensed matter and deuterium for the U.S. Department of Energy for 5 years and for the Electric Power Research Institute. He has also received numerous awards in the U.S., including the David David O. McKay Scholarship at Brigham Young University in 1968, and a tuition scholarship and research fellowship at Vanderbilt University from 1973 to 1978, an Outstanding Young Scholar Award from Brigham Young University in 1989, and the Best of What's New for 1989 from Popular Science. He got the Brigham Young University Young Scholar Award in 1990. His specialty has been in metal-catalyzed fusion, archaeometry, and solar energy. His fusion work should not be confused with the more controversial work of Pons and Fleischmann. He taught physics at Brigham Young University for over 21 years, and he elected to retire so that he could spend more time speaking and conducting research of his own choosing. He realizes the importance of the investigative work that he has begun and hopes to encourage his peers in academia to join him in the pursuit of truth as to why the World Trade Center collapsed and to publish their findings in internationally recognized scientific journals. We are in his debt for bravely casting light on what must be recognized as the crime of the century. Please join me in welcoming Stephen E. Jones.
Thank you. Well, that was a great introduction. Thank you, Carol. I had a flash from it that maybe this was my, what do you call it, at your funeral when they tell all these wonderful things. But no, I'm here in the flesh, and I'm very, very pleased to be here with you today. So I will be talking about scientific method, and I'll home in on dust that was discussed this morning and our analyses, scientific analyses of the dust, and also the liquid metal samples that we've been able to obtain. And I'll talk about the collapses of Building 7. You've got to see that if you haven't seen it before. That's what got me interested in this. Actually, it was early part of last year that I jumped in, and it was the collapse of Building 7 that really got me going on this. So I do have a paper, as Carol mentioned. It's published in this book, edited by Peter Dale Scott and David Ray Griffin. And Peter Dale Scott is here. Pleased to have you here today, Peter. There's been a lot of controversy about whether it was peer-reviewed or not. It has been peer-reviewed, and Professor Griffin told me that there were 4 reviewers as he counted them, and 2 of them were 4 PhD reviewers. 2 of them were physicists. And of course, the names are not disclosed in general. These are blind reviews. That's the normal procedure in science. This paper for a long time was on my research web page, and when I realized I would have to move that, I also submitted this paper to the Journal of 911 Studies, where it's available now online with the permission, the kind permission of the editors of the book I just referred to. So you can read this paper also here, Journal of 911 Studies. It underwent a separate, it underwent a separate set of peer reviews for publication in this journal. So this paper calls for an investigation. I'm curious, how many of you have had a chance to look at this paper? Let me just get a feel. Okay, but not everybody, so somewhere around 40–50%. And I would encourage you to look at it. I put a lot of work into it. We're still learning, of course, and I'll present new data today. That is to say, some of the material that I cover is in the paper, but a lot of it is not. It's new, and we keep. In fact, I spoke last week at Sonoma State University, sorry, and I have some new material since then. So if you were here or there last Friday, a week ago, you'll see some new material already this week as we continue to do research. And I am working with some colleagues still at my university, university where I'm retiring from. It's a funny story. Maybe I'll talk about it a little bit, but not too much, because there are more important things, and I do want to give you the data. So I was able, after getting this paper out there on the net and getting it available to people, I called for an investigation and requested samples of the dust and also of this, you see the molten metal pouring out of the South Tower. Well, I was seeking samples of this molten, solidified now, but previously molten material. And I was able to obtain samples. So this paper has been a success in that regard. And I believe, as Carol mentioned, that others, as they look at this, they think, well, there is something here to look at. This is serious business. It is not just nutty, freak, what's the fringe, I guess, science. This is real science, as I hope to demonstrate as we go along. And in fact, now we feel that, my colleagues and I, that we have sufficient data to where we'll be able to publish discovery papers in significant scientific journals as we proceed. So, yes, I do have this slide here. I will retire end of the year, actually. And I want to point out a couple of things. The university talked about having a review of my research, which I welcomed, and also my teaching. I have 2 teaching awards at the university, one which was granted last year, and which has provided funding for the research I'm doing on 9/11, incidentally. So. And so, it's a friendly arrangement, I will say that, and I believe the university's been fair with me in that. Okay. There is considerable support at the university, actually, and I just want to point out my friend here, mathematics professor Ken Cutler. Let's see. I'm going to have to read this way. He is a bit surprised by some of the events. I feel sometimes people criticize Jones for the things he didn't even say. Of course, that happens fairly often, That's why we write papers, so you can see what I really did say and read it for yourself. I believe there's a little bit of guilt by association here. Yeah, one professor came to me recently, and he was talking to me. He said, "Boy, I'm sad to see you go. You've been such a great teacher and professor and so on." And I said, "Well, have you read my paper?" And he said, "No, I don't believe in UFOs and conspiracy theories." So I was disappointed, needless to say, in that reaction. Guilt by association. I mean, I was very interested in the molten metal in the basements of the both towers and Building 7. Yes. It seems a legitimate question to ask. A man trained in physics has every right to ask it. Thank you, Ken. That's what he has emphasized all along. He's interested in this thing about the molten metal in the basement and other anomalies, and why not? And so there has been that support, and that's what we'll talk about today. Now, I do want to set a bit of a background. My first paper, my first major publication in which I was first author is this paper. It's on muon-catalyzed fusion, which is a type of fusion which occurs in the sun, right, at high temperature. This occurs at room temperature. And the trick is that the muon, which is basically a heavy cousin of the electron, pulls these nuclei, hydrogen isotopes, deuterium and tritium is what we're using, pulls them very closely together so that you get tunneling through the Coulomb barrier and fusion. How many understood? Okay. Anyway, look, years ago I was on this campus visiting Luis Alvarez, who had observed muon-catalyzed fusion experimentally for the first time in a hydrogen bubble chamber. And if I'm not mistaken, it was right there at LBL. I'm pretty sure that's where, I'm 99% sure of that. Anyway, it's great talking to Dr. Alvarez. He has since passed away. He was a no-nonsense kind of guy, a very creative fellow. he and his son, if I'm correct again on my memory, came up with this idea that the Earth, the major change occurred because of an asteroid striking the Earth. Now that theory was very unpopular when it first came out. It has since been verified by experiments so that it has now become accepted. But it takes time. And Luis Alvarez set that example of not being afraid to voice unpopular hypotheses, we call them in science, and then proceeding with experiments and encouraging others to do experiments to get an answer. That's what we do in science, whether it's popular or not. That's the idea of science, is free inquiry, free speech, and experiments to determine what is correct and what's true. A next paper then was challenged. This also brings me to this campus. We reported in this paper, Physical Review Letters, which is the premier journal in physics, still is, I would say. We reported a very small muon alpha sticking coefficient. And one of the professors here in the physics department, I won't name him, I remember very well his name. He's quite a character, very stubborn guy. But anyway, he said, no, you can't possibly be right. You're challenging J. David Jackson, which I was. Now, those who know Jackson, who was also here, right? Am I correct? So Jackson had looked at the alpha muon sticking coefficient. It was supposed to be around 1%. We measured it in liquid deuterium tritium at 0.42%, as reported in this paper. That's way, over a factor of 2 smaller. So, he really raked me over the coals. Couldn't possibly be correct. But, it was correct. But it took a subsequent experiment to test our results and verify that we were correct in that. So again, you see what I'm kind of setting a background here. It's experiments that determine what's correct, not somebody's theory, even somebody very famous like J. David Jackson. And now it's understood, of course, why fairly well understood anyway, why this alpha muon sticking was so small as we measured it. Next major paper was in Nature, 1986, and the British Scientific Journal. And I want to point out that generally it takes years. Now, by this stage, I'm about 7 or 8 years into the study of muon-catalyzed fusion. So you can't expect a major publication after a year and a half, which is about how long I've been studying what happened in 9/11. Nevertheless, we are approaching a major publication already, I think. I'm not sure Nature will publish it, or Scientific American for that matter. But my good colleague, Professor Jan Rafalski, Johann is his full name, but a great Jewish scientist, a friend of mine. And I published this paper in Scientific American. We called it Cold Nuclear Fusion. We probably couldn't get away with that title today because of history since then. But this is referring to muon-catalyzed fusion again, which by this time was not controversial. It had been verified. The low sticking that I talked about had also been verified, and so on. And then this is 1989. Now this, talk about controversial. This is what's called cold fusion, but not the Pons-Fleischmann variety. And our variety we had been studying since 1985. Looking at fusion catalyzed now in metals. In other words, somehow metals would enhance fusion. Now, as we think about peak oil, Jenna mentioned this morning, and there are concerns about oil, fusion has a lot of hope. So you see, these stories kind of interweave. This particular paper received a great deal of criticism because, well, again, partly because of guilt by association. People thought we were supporting Pons and Fleischmann, but we were not. We were actually saying, no, this is much smaller than what the report. You remember those guys, those of you who weren't on Mars in 1989. I mean, that was all over the place. and they were claiming excess heat and so on. We were claiming neutron production. They were claiming excess heat without neutrons, which was one of their big stumbling blocks, and in fact proved to be, I would say, the death knell of their approach, because it works out, it violates laws of physics if you don't have neutrons coming out of the DD fusion, deuteron fusion. Here's a photo of me back then. I was a little thinner in those days. Okay, were we wrong? The answer is, of course, I wouldn't be telling you this if we were wrong. No, we were correct, and the result, it took 9 years to get this verified. Finally, experiments in Japan and Europe have published now, and our hypothesis that metals would catalyze, that is, enhance fusion, and different metals would do a better job than other metals has been completely verified. And here's a list of the metals. Palladium is, no, actually palladium-lithium alloy is the best alloy that's been found so far. This number 1500 for the screening potential works out to be very large, surprisingly large. Actually, if we continue on this path, there is not any funding in the United States anymore as far as I know, but there is work going on. We're actually doing work, but I mean no funding, okay? No direct funding. It's funny, isn't it? I mean, it's an unpopular field in the United States because of the guilt by association and so on. It's kind of sad, because there's a lot of hope here for at least understanding nature. We may not get to an energy source, but I wouldn't rule it out at this stage. We haven't hit a fundamental barrier yet. And I might add, my university is going to let me continue to study this. I do have some students working with me on this. So, you know, see what I mean? It's kind of a friendly arrangement we have. I'd read that quote to you if I could read it, but you can read it for your, just the last part of it. Their experiments can explain the neutron production rate observed by Jones et al. So this refers back to our 1989 paper in Nature. So they say, look, the rates here are consistent and confirm and can explain the results back then. So we finally have confirmation. 9 years. Now, I don't think we have that much time for this. I'll skip this. Print's too little. So, now, with this background, so what is the scientific method then? First of all, in a new field, so let's say we observe the collapse of the towers. Now, everybody's seen that. And we gather observations. That's just one observation, the towers collapsed. And then we can time how fast they collapse. Turns out to be around 10 to 14 seconds for the towers, 6.5 seconds for building 7. And next, but there are more observations too. The metal flowing out of the building, this orange flowing material coming out of the South Tower, which we'll talk about. The molten metal pools afterwards, the dust itself and what's in the dust. See, all of these provide data. Now, next you formulate a hypothesis to explain the data as best you can. And then you do experiments to test. You're not done, by the way, once you just formulate a hypothesis. Next, you do experiments to test your hypothesis and generate more data that way. And as you go through this procedure, then you refine your hypothesis. Sometimes you have to reject it entirely. Sometimes you come up with a new hypothesis. And you go back and do more experiments, always gathering data as you go along. Finally, you publish in a peer-reviewed journal. This is part of the modern scientific method and has been since the time of Newton. And then you repeat the cycle. Hopefully others will join in studying this. And finally you generate a theory. This is what we now call a theory. Not in the vernacular, a theory is more what we call as scientists a hypothesis. But a theory now is an explanation, a model of reality. After all this work and experimentation and interpretation and analysis, you finally generate a model of reality. Now, we are presented, in the case of 9/11, with a model of reality without having to do much work. We were told it was 19 hijackers crashing planes into 2 towers and brought 3 skyscrapers down. And we are told, we'll look at that hypothesis. This is the official, what I call the official conspiracy theory. Surely you recognize those 19 hijackers did not work independently and individually. They conspired. That's a conspiracy. And so the official story is certainly what would be fair to call a conspiracy hypothesis. On the other hand, we are going to look at a hypothesis that explosives were used to help bring these buildings on. Of course, they were hit by planes. I actually, not even everybody accepts that. But the evidence is very strong. The evidence is very strong that real planes hit the towers. Okay. And we can look at the evidence. That's part of the scientific method. Okay, so we got these 2 models which we'll compare as we go along. The use of explosives and 2 planes brought 3 skyscrapers down. That's all. Okay. Now, the goal that I have and others that I work with is to publish in a major scientific journal results. And that really then will, based on, again, experience, get things out into the public where they can't just say, oh, it's some discredited professor, without explaining why or who discredited him or what, Okay, but anyway, it's out there in a journal. That'll help. So we'll talk today about the fall time of Building 7, the fall times for the towers, challenging the NIST report and their recent fact sheet, August of this year. In particular, I'll home in there on molten metal flowing from the South Tower. And we'll talk about other evidence for the use of thermite reactions, looking at what's in the dust and this solidified slag. First, then, is the collapse of Building 7. Now, here are shots showing at 1-second intervals. So we just see the building. We're looking, by the way, at the southwest corner of the roof. There is some activity in the central area, you can tell, because there's a kink that actually appears. And then shortly after, then you find that this southwest corner of the roof begins its steady fall to the ground. And we look at the time for that. 1, 2, 3, 4, 5, 6.5 seconds. I believe this particular slide is due to Jim Hoffman. Give him credit. And pretty sure it's from Jim. By the way, it was looking at WTC7.net and seeing the collapse of this building that really got my curiosity stirred, as a scientist. Bless you. So we look at how fast it would a steel ball would fall. So you stand up on the roof there and drop a steel ball off the corner of the roof. How long does it take to hit the ground? 6.0 seconds. And the collapse of the roof, 6.5. Well, that's almost free fall speed. Now, how do you do that? Because there's a lot of steel and concrete between the roof and the ground. So that immediately raises a question. We have to, after all, in science, consider conservation of momentum. It's something I teach students. And by the way, I do have an offer from another school, which I may take up at some point. That's just came to mind. So I like to teach, and the conservation of momentum is one of my favorite topics. In fact, back to the Pons-Fleischmann story just for a minute. They were talking about producing 2 deuterons coming together, producing helium-4, and then the rest of the energy gets absorbed somehow in the lattice of the metal. And I pointed out that I could not see a way to do that and conserve momentum. And I went through the arguments. And as I explained that, a professor from MIT, Peter Hagelstein, actually, a good man, as he listened to my arguments, he was a supporter of Pons and Fleischmann's, actually, at that time. He said, as I explained the conservation of momentum argument, he saw the guillotine blade fall on Pons and Fleischmann's idea. And that was true, And the same thing applies here. Now you get to see, in other words, we're going to apply conservation momentum. On the left, you see the collapse of Building 7. If you haven't seen it before, you get to see it in the afternoon, 5:20 p.m. on September 11th, 2001, about 7 hours after the collapse of the towers. On the right, you see a collapse of a building in, I believe this is Oslo. And I've timed a number of these collapses that are done by explosives. And it's interesting that as I time these, it's often the case that, again, the roof, as it starts to move, it's just about free fall time for that roof to hit the ground. You calculate the height of the building, the time it would take. And it's just about free fall, just as Building 7 is just about free fall, as if something's moving the material out of the way beneath the roof. Something like explosives, for example. Yeah. Little green, yeah. UFOs, that's right. Okay, so, now, now, interestingly, the 9/11 Commission report fails to even mention the collapse of Building 7. A little oversight there, yes. The NIST report on Building 7 is long overdue. We'll talk a little more about that as we go along. They do have photos, NIST does, of Building 7's collapse and videos, but they have actually refused to release those, despite Freedom of Information Act requests, and their excuse is, well, we're still studying this. But, you know, these photos and videos were obtained mainly from the public at taxpayer expense, and we feel like the public should have a chance to look at this so we can study this for ourselves. And not that we don't trust them, but it's just in science. Okay, not totally. In science, we like to look for ourselves, you know. We like to look. And we have this Scholars for 9/11 Truth group now, which formed about last December. You can find it at st911.org. In fact, you can join us, and I hope you'll consider that as you go there. Just click on at the top, join us. And we have about over 100 now full members. These are predominantly academics or retired academics or retiring, and we have a total of about 400 members of this group. And we continue to study together these data that I'm describing today. Anyway, we offered to NIST to sit down with them, debate or sit down. They declined. We had a certain time and place. We said, well, look, you name the time and place. Can we just sit down and talk? And they said, a change in venue, a change in time will not change our decision. But we do have a little bit of discourse going with NIST. This is the National Institute of Standards and Technology, a federal laboratory, and I will talk a little bit about the dialogue we have with NIST. Okay, here's David Griffin's. Oh, sound. You're plugged in for sound, but I don't hear any sound. I think it's
which only a few companies in the world are qualified to pull off. Third, these buildings collapsed at virtually free fall speed, which means that the lower floors, with all their steel and concrete, were offering virtually no resistance.
Okay. All right, well, that's all for now. We'll hear, sorry, but it shows, and that was something that Ken Jenkins put together, that comparison of the collapse of Building 7 and another, it was Landmark, I believe, tower. And that will be shown later today, if I'm not mistaken, so you'll get to see that again. Okay, Building 7 on the afternoon of 9/11 is shown here. This is this 47-story skyscraper. And this is viewed now from the WTC-1 area, post-collapse, looking over at the Building 7. It was about a football field length away from the closest tower, the North Tower. So it's quite a ways away. The FEMA report does discuss the collapse of Building 7. They say that the fires in WTC-7 and how they caused the building to collapse remain unknown at this time. The best hypothesis, which is fire and some damage, then complete collapse, has only a low probability of occurrence. Now, to their credit, they make that admission. You know, their best hypothesis has only a low probability of occurrence. Now, this, remember, is this hypothesis, the official fire and damage hypothesis. Now, if your hypothesis has only a low probability of occurrence, as a scientist, what do? You think, well, let's consider another hypothesis, you see, right? Okay. Thank you. Okay, and I've got an eye on the time, so I'm just going to skip some of this. I do want to point out there was some damage. This is in the preliminary NIST report, talking about these columns being damaged, the ones circled, and not severed as far as we can tell. But you see, again, 24 steel core columns and 57 perimeter columns. This is not an insubstantial, and on the contrary, it's a very solid building for it to come straight down at nearly free fall speed. Without explosives, frankly, strains the credulity and leads us to say our best hypothesis has only a low probability of occurrence. Unless you look at the hypothesis of explosions, then it matches very well, as we've seen, of course, the collapse of the building. Here's a paper done by this friend of mine, Professor Cutler, still at BYU, he is. And you can read it in Journal of 911 Studies. Let's go through this equation then, as we, no, I'll leave that to you to. Okay, I do want, though, to read with you this footnote in Ken's paper. Any further analysis of the collapse of Building 7 should include all floors, not just floors 8 to 46, and conservation of momentum considerations, which he does consider. Now, why would he say this, not just floors 8 to 46? Well, he points to this NIST solicitation. So NIST, as they're studying the collapse of the buildings, they decoupled, their term, the study of Building 7. Finally, earlier this year, they commissioned, first they solicited proposals for someone to study the collapse of Building 7. The grant went to ARA, company in New Mexico. But here's the solicitation that went out from NIST. Create, this is related now to the collapse of Building 7. Create detailed floor analyses to determine likely modes of failure for floors 8 to 46 due to failure of one or more supporting columns at one or more locations in WTC-7. Now that, to me, is not a very scientific way to proceed. We want to understand the collapse of this building. And yet they're asking whoever accepts this request to put blinders on. Only consider floors 8 to 46. Now, as a scientist, what does this make me want to do? It makes me say, what's below floor 8? What happened below floor 8? And also floor 47 and above, too. That sounds interesting, but particular below floor 8. Well, it turns out in the latest, this is Loose Change Final Cut, they have a fellow who was trapped in Building 7 before it came down. So he's on the radio telling how they got out of there. He said what happened was there was an explosion. They were trapped at floor 8. He said there was an explosion below us, he and his colleague. We were trapped. The explosion cut off our escape routes, the stairs and so on, elevators. So there wasn't any way that we could find to get out. Now that's a fairly major explosion. This is before it collapsed. And he said the firefighters were able to get to them and get them out of Building 7 before it collapsed. Now this is evidence for explosion, floor 8 or below. Therefore, we, to be scientists, we have to include that data and not just limit ourselves to floors 8 to 46. It's a little bit funny, but it's sad in a way. And I'm hoping, and let me be a little bit blunt here. There have been other cases where, for instance, global warming studies have been fairly suppressed. I think it's fair. The researchers have complained that there's a suppression by the current administration on their studies and their publications on global warming in the past. Now, I'm hoping that with the change that we just had in this election, that there will be some opening up, and we'll be able to look at all the floors in Building 7 and not just floors 8 to 46. Okay, that would be one great outcome of this election. Freeing up science and so on. We do have some structural engineers down at the bottom. I quote Joseph Phelps. He's on the editorial board of our Journal of 911 Studies. And he said the airplane couldn't cause this. He just wrote this in a letter to me. But something is cutting the columns. It's called controlled demolition. And two structural professors over in Switzerland are in the newspaper there. Here's the reference, Toggs, Angziger, September 9th of this year. The first one, Hugo Bachmann, says, in my opinion, WTC 7 was with the utmost probability brought down by controlled demolition done by experts. I've had people say, well, maybe the, Al-Qaeda ran in that morning, planted explosive. No, it takes time and effort to do this. And of course, this was a highly secure building. Building 7 housed a secret office of the CIA, as well as Department of Defense office and so on. Records of Enron and some other businesses under investigation were lost and destroyed when this building collapsed. George Snyder, well, you can read, WTC 7 was with the utmost probability brought down by explosives. Now, of course, I'm hopeful that NIST will actually go so far as to consider explosives used in the collapse of Building 7. You don't think so? Okay, what's this? Oh, this, just to show you that this Building 7, and this is in Italian, so I won't plug it in. It's on a debate show called Matrix, interestingly enough. If you've seen that movie, there's some correlation which we won't go into. But the collapse of Building 7 is again going to be compared. Here's Building 7. Here it is, Building 7 and a controlled demolition in slow motion. So you can see how they compare. And this is in Italy, and this gives me a chance to remind people that this study of what happened on 9/11 is not just going on in the United States. And there is actually quite a bit of opposition, it is certainly fair to say, in the United States to this study. But it is going on elsewhere. And Italy, to their credit, has done has had quite a lot of discussion about this. And I understand Denmark, the Netherlands, Sweden, and so on. Okay, but we already know who did it, don't we? I mean, what you know, we've already got the explanation. This is okay. It's a little comic relief here, just from that before we go on. Yeah, very heavy arrow. But yes, I mean, if you know the explanation in advance, then why bother with a study? But of course, that's an unscientific method, where you start with a conclusion and then you find facts which will support your conclusion. For instance, fire did it, just look at floors 8 to 46. Now tell us, just give us how that occurred. No, in the scientific method, we gather all the facts, and furthermore, we do experiments, and then we draw our conclusions based on those facts and experiments. Okay, building 7 is done for now. Fall times for the towers. The 9/11 Commission report described that the collapse of one of the towers was in 10 seconds. I actually think that was building 1 now as I think about it. And the free fall time for, again, a steel ball in vacuum dropped off the height of the tower, 1,368 feet for the North Tower, is 9.2 seconds. The NIST final report avoids this question, of how fast the towers collapsed, because, as they say on page 142, they only take the analysis, the NIST analysis only goes to the point where the towers are poised to collapse. They don't look at the actual collapse or the molten metal afterwards or anything, just to the point where you're poised to collapse. So frankly, they're ignoring a lot of data. Here's a study in Journal of 911 Studies, which you can read, by mechanical engineer Gordon Ross. Now, I just want to, you can read it, especially those who are technically minded. It's fairly technical paper, but let me just lead you through this a little bit. He's looking at building 1, that is the North Tower, and the North Tower was hit at about floor 96, and of course damage for a couple floors there, 2, 3, 4. And so you have this block of floors, about 13, 14, 15, I'll just say so we can talk about it, 14 floors sitting there. And below that you've got this damage where some of the core columns were knocked out. And plus you have fires, which of course the heat is rising, so there's this damage going on. Now, Kevin Ryan, also in the Journal of 911 Studies, analyzes the question, will fires be sufficient to cause failure in this support, in the building? And I'll just let you read Kevin Ryan's paper. He's done a good job at that. I'm tempted to say, I will say one thing about that, as Kevin pointed out, and which he was fired, by the way, for exposing this and talking about it publicly, is this. NIST commissioned Underwriters Laboratories to build floor assemblies and subject these to severe fire endurance tests to see what would happen when these actual WTC floor assemblies, you see, were subjected to fire tests. The Underwriters Laboratories did this. The floor assemblies did not fail. There was some warping. Kevin Ryan says about 3 inches vertical warping was observed, but the floor assembly certainly didn't melt. We wouldn't have expected that, but they did not fail. Now, in the NIST report, then, the final report on the collapse of the towers, they resort to computer simulation, which is okay, but it's not as good as experiment, right? A scientific method, we really like to do experiments to find out. Here's an experiment going against the fire and damage model, the official conspiracy theory. So NIST, in their analysis, now allows warping of not 3 inches, which was experimental, but over 40 inches. I think it was 42 inches. Now that's a major extrapolation from the data. You see, again, scientific method. But let me lead you through Gordon's paper just a minute. It's kind of interesting to do this. So you take these 14 floors at the top, and we're just going to let them fail. Okay, forget the experiments that say fires may not even cause this to move, but or at least not completely move. It might slough over, that sort of thing. But we're just going to drop it. We're going to remove a floor and just drop these 14 floors. Just drop them. Now what happens? 2 things. The first is a little easier. We'll take this 14 floors with a huge crane and we'll drop it in air. Free fall time, about 9 seconds. Now we'll take these 14 floors and drop them on the remaining tower, which is 90 plus floors, about 200,000 pounds of steel and concrete, 47 core columns, 240 perimeter columns, a lot of material in the way. So one we're dropping in air, right, these 14 floors above where the plane went in, and the other one we're dropping on the steel building and concrete below. Now just, you know, your own experience when you've hit things in your car, it slows you down, right? Okay. Now, which is going to fall faster? The 14 floors dropped in air or the 14 floors dropped on the remaining 90? Air is going to fall a lot faster. And so when you go through the calculations, and Ken Cutler has done this for the tower, particularly for this North Tower, it takes a lot longer because of just conservation momentum. And it takes, and energy. And he's getting numbers around 40 seconds, Ken Cutler is, for the collapse of the towers. And that is not considering the strength, the give in the core columns. Now, if you consider that, then Gordon Ross says it might not even collapse at all completely. I mean, it'll go a ways. Yeah, there's damage, of course, but the core columns below flex and absorb that kinetic energy. Plus, you've got pulverization going on, which removes kinetic energy. And as he looks at conservation of energy and momentum, he finds that it actually stops. The collapse is arrested. It doesn't go to completion. Well, I mean, why would we assume that it would just give up all this material below, which is designed to stand? These buildings are designed to continue to bear weight. And so it might not have collapsed at all if there hadn't been something weakening the building below, like explosives. And it certainly wouldn't collapse as fast as free fall speed, or nearly free fall speed, without moving material out of the way. This is what's done in controlled demolition with explosives. Then you do get near free fall speed as you time these controlled demolitions. Okay, so there's a lot of evidence for the use of explosives. Photograph inside one of the towers during construction. You see the core columns. These are not hollow tubes. Let's see, a little story. I'll skip it. Maybe I'll tell later. We'll see. After the columns, the towers have collapsed, you see some of the perimeter walls standing, but oddly enough, these enormous core columns are gone. Certainly, you don't see stacked up floors. Pancaking is not a viable hypothesis anymore. Even NIST, in their August report, they explained, yes, that is, they don't use the pancaking hypothesis either. This is what you get with actual pancaking. You get floors stacked up like pancakes. That is not the case over here. There's no pancakes. I'm going to have to skip for time. So I want to emphasize that NIST is what I call the official pre-collapse theory. A friend of mine pointed that out to me. Quoting from NIST, so you don't think I'm just making this up, they say in their report, it does not actually include the structural behavior of the tower after the conditions for collapse initiation were reached. And then down below, they talk about results were a simulation of the structure deterioration from the time of aircraft impact to the time at which the building became unstable, i.e. was poised for collapse. That's as far as they go. But all this data, all this information, the speed of collapse, the molten metal, the plumes, which we sometimes call squibs, coming out of the building during collapse, the eyewitness of flashes and the sounds of explosions, boom, 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 you know, all of that data they basically are overlooking here by only considering in their analysis that which happens up to the time the buildings are poised to collapse. Now in science, we don't want to do that. Good science considers all the data and comes up with an explanation to account for all the data. Structural engineers immediately complained about the NIST report. I'm not the only one complaining about it. Kevin Ryan complains too. But in the new Civil Engineer, October of last year, they pointed out World Trade Center disaster investigators at NIST are refusing to show computer visualizations, despite calls from leading structural and fire engineers. Let's look down here. Leading U.S. structural engineers, talking about NIST. The software used by NIST has been pushed to new limits. There have been a lot of simplifications, extrapolations, and judgment calls, which means we don't have a lot of confidence in a computer simulation, particularly when these extrapolations, like the 3 inches to over 40 inches in the warping of the floor assemblies. I'll skip that one. Critique also of the FEMA report, which was the first one to come out on the collapse of these buildings. Respected members of the fire protection engineering community are beginning to raise red flags, and a resounding result has emerged. Now, this fellow is not talking about, you know, an alternative or explosive theory, but he's just complaining about the FEMA report. I need to clarify that. The structural damage from the planes and the explosive ignition of jet fuel in themselves were not enough to bring down the towers. Fire Engineering, that's the name of the journal, of which he's the editor, has good reason to believe that the official investigation, blessed by FEMA, is a half-baked farce. This is pretty strong for an engineering journal, you know. Okay. That may already have been commandeered by political forces whose primary interests, to put it mildly, lie far afield of full disclosure. Clearly, there are burning questions that need answers, and that's what we're saying. A full-throttled forensic investigation is imperative. Unfortunately, and over the protest of fire and other engineers, nearly all, 99.7% approximately, of the World Trade Center steel was quickly shipped out to Asia, melted down and destroyed. And this also in science is a big no-no to destroy. And also in a crime investigation, to destroy evidence is very bad. This little cartoon lightens the load a little bit. So here's this scientist. After years of laborious study and research and calculations, he comes to the conclusion that no two snowflakes, are alike. And that's easy if you and notice at the bottom, this is extremely pathological science. Here the scientist more than overlooks negative evidence, that is evidence that goes against your favorite hypothesis. He destroys the evidence. This is pathological science in the extreme. Let's call it for what it is. And then they say, I'm discredited. I mean, no. Okay, here we find the next topic now, molten metal pouring out of the South Tower just before its collapse. So we give you this view, and this is north face. This would be northeast corner. I'm pretty sure I'm right. Yeah. And you see, now we're going to get, because I think it was Ken Jenkins, wasn't it? Or Hamuk, that pulled out for us a stabilized image of this and slowed down by a factor of about 2. And so we'll get a better view now of the molten metal. And if you look at this, you'll see this orange glowing, yellow-orange glowing material flowing out at floor 80. And you'll see the 1, 2, 3 over, and also the 4th over. You can look in and see some of this metal flowing out. Notice this corner. We'll come back to that corner in just a moment. So these again, and the white wispy ash or smoke drifting away. It's not gray smoke like the fires producing, but this white ash drifting away. That's characteristic of whatever's happening. So, 4 possibilities for this. Now, these are hypotheses. Somehow, perhaps the structural steel in the building melted and is flowing out. Perhaps it's molten aluminum from the aircraft. This is at about the floor where where one of the jets then came through. This is the south tower, but not the corner where it hit. It's quite a ways away. But perhaps, nevertheless, aluminum melted from the aircraft and is now flowing out, or a mix of the above, including office materials, plastic, wood, wallboard, carpet. The other possibility, which, on the left here, basically those are all consistent with the official story, at least possibly consistent. On the right, we have the alternative hypothesis that the molten metals arise from highly energy-releasing exothermic chemical reactions, such as thermites. And the technical term, I'll probably say thermites because it's easier to remember, not termites, mind you. Okay, thermites. Okay, but aluminothermic reactions because it involves aluminum and it releases heat, thermic. First hypothesis was molten steel, and let's quote Professor Eager, and I agree with his statement. The temperature of the fire was not unusual. It was most definitely not capable of melting steel. Dr. Gale, NIST, and this is in the NIST report, and they talk about this. Your gut reaction would be that the jet fuel is what made the fire so very intense. A lot of people figured that's what melted the steel. You remember early on they talked about steel melting. But no, that's not the answer. Indeed, it did not. The steel did not melt. If we look at the NIST report, they actually show the maximum temperatures released by columns. And here you see the core columns displayed as well as the perimeter columns. You can tell which columns were knocked out, where the planes went in. That's not throughout the building, of course. It's just where the planes severed the columns. And this is the this is the north tower. This is the south tower. Where we saw that molten metal coming out is over here, the northeast corner. Where the plane went through is like this, the southeast corner. So, but I grant that it's possible that some molten aluminum might have. I mean, we're pushing it, but it flowed across and come out. So that's the next hypothesis. But it's nowhere near hot enough at about 600 centigrade maximum to melt the steel. Steel melts at 1500 centigrade. Okay, it's 2800 Fahrenheit. And again, in their fact sheet, NIST, in no instance did NIST report that the steel in the towers melted due to the fires. And then they go through the arguments I just reviewed briefly. The fire is just no way hot enough to melt the steel. And remember, too, that this steel is interconnected. There's a lot of it, 200,000 tons, roughly, of steel in each structure interconnected. So as you heat one portion of the steel, that heat is wicked away, heat transport, so that it's very difficult to reach conditions of steel melting, no way. And failure even is, of course, very difficult. This is Kevin Ryan's paper. Now, this corner, so the flow is over here that we looked at. In the corner, NIST has this photo. And they have lots of photos, which I wish they would release to us. The unusual flame is visible within this fire. A very bright flame as opposed to typical yellow or orange of surrounding flames. It's generating a plume of white smoke. Now, you keep that in mind as we look at this thermite. Okay, I'll just tell you. Thermite reaction has an intense, bright, it's white initially, reaction region, and the white smoke drifting away from thermite is aluminum oxide. And you'll see that in our experiments. They don't mention that possibility here of thermite, but they do at least describe the data reasonably well. That's good. And here's a little more now in the fact sheet. NIST reported just before 9:52, this is a few minutes before collapse, about 4 or 5, I think. A bright spot appeared at the top of a window, 80th floor, building 2. 4 windows removed from the east edge of the north face, followed by the flow of a glowing liquid. So first we have the bright spot, and then right after that we have this glowing liquid. This flow lasted approximately 4 seconds before subsiding. Many such liquid flows were observed from near the location, this location, in the 7 minutes leading up to the collapse of this tower. So this is a significant event. Bright flash, white plume drifting away, followed by this yellow, orange, glowing material. What in the world could that be? Well, those of you who have seen thermite, you know. But anyway, they conclude that the source of the molten material was aluminum alloys from the aircraft. Okay, well, so what do we do to test this hypothesis? Now, look, just because NIST says it, that doesn't mean it's true. You see, we do experiments. This is science now, modern day. No more Aristotle, you know, he said it, we're done. No. NIST says it, we still do experiments. Oh, I want to show you how important this is. A video now showing a different videographer. You can see a little molten material still, and we're going to see the failure at this corner, the northeast corner. If you watch, it's going to occur about now. Here it comes. 3, 2, 1. This is significant. Something happened. There is some sound with this, but I won't, you know, people concerned, obviously, and surprised. Okay, so we do experiments. Colleagues, we actually then heated up aluminum alloy in a steel pan, and we poured it out. And the aluminum appeared silvery. Not yellow, orange. We heated the steel pan till it was a yellow-orange color and poured out the aluminum. It still appeared silvery. I talked to a colleague of mine about this. It's well known, actually, but he explained the reason why aluminum appears silvery. See, metals incandesce as you heat them, like in your light bulbs, right? Incandescent light bulb, you heat it up and it glows. Metals glow as you heat them up. Red hot is about 600 centigrade. Orange hot takes you up to about 1,000 centigrade. So, and aluminum melts at 600, right? Well, alloys, it varies, but around 600 centigrade. So, two things. First of all, how do you get the aluminum, if it's aluminum alloy, how do you get it up to 1,100? I mean, it melts at 600, so here's this plane and these flames, it melts, and then the material, the aluminum flows over the window, but it's orange coming out. So how do you get it to 1,000 degrees? It melts and flows away from you. Unless there's a big pan inside the building there, it's hard to get it to that yellow hot temperature. And then even if you do, because that's what we did here, we heated the pan to the orange hot temperature, orange yellow, but the aluminum is silvery still. The reason is that aluminum has lots of free electrons. It has high reflectivity, as we all know, it reflects a lot, but it has low emissivity, which means that, yeah, it's glowing, but it's very faint. So in daylight conditions, it looks silvery from the reflected light. See? It's interesting. Aluminum is different from steel and iron and many other metals in that way. Okay, NIST responds to our questions. So I pointed this out in my paper, that this could not be aluminum because it's silvery. And I reported these experiments. It's in that paper that I discussed at Journal of 9/11studies.com. So NIST concluded that the molten material observed coming out of Building 2 before its collapse was aluminum alloys. These are known to melt between 475 and 640 Celsius. Aluminum is not expected to ignite at normal fire temperatures. That's true, by the way. Remember that bright flame? How did that come? You know, it's what we did is we took an oxyacetylene and torch and put it directly on aluminum. We couldn't get that stuff to ignite. Now, it does peel off as aluminum oxide layers, but getting aluminum to burn is not so easy. Anyway, going on with NIST. However, the molten metal was very likely mixed with large amounts of hot, partially burned, solid organic materials, furniture, carpet, etc., which can display an orange glow. Now, I read that word can. And I think as a scientist, I want to do experiments, right? And I wonder, why didn't they do the experiment and show me how to do this trick? But the way we find out what molten aluminum looks like when you mix in organics, do your best, which we really did try. We do experiments. On the left, we see we've mixed in wood chips. Oh, the sound's off. That's good. It's quite noisy because of the oxyacetylene torch. We heated the aluminum. We mix in chips, and we're pouring out the aluminum, and it looks silvery. It's a little hard to see but here we go again, another try. We've mixed in plastic, wood, and as you pour it out, it appears silvery. And you get these embers flowing up. And this just doesn't look like what happened at the South Tower. I reported that, and a friend, a colleague there at my university I'm retiring from, and he came to us from NIST, and he said he just couldn't believe that NIST would make a statement without, he said it should be easy to mix in something, organics, ash, with aluminum chips and get that to glow orange when you pour it out. So I said, well, okay, you come help me. We'll work on this. And we did this experiment then again. This time, as you can see, I have wood ash here from my wood stove. Put some in the steel pot. I mixed in aluminum chips, plastic chips, pieces of carpet. Later we mix in glass. We melt the whole thing. Turns out it's harder to melt now because the dust is an insulator. So, that's already a problem. But anyway, we worked on it. We worked on it for over an hour. And I'm going to show you what happens here. These are short clips. Here's heating together the mix. And you see, we're getting it to a nice hot temperature. Oh, let me try the sound here. No sound. Okay, I'll just tell you what we're doing. Okay. All right, so here I'll show you. Here he is. He's got a long screwdriver there, actually, and he's mixing this brew of aluminum and ash and all this organic material, plastic, carpet pieces. He's mixing it together. And he mixes and mixes. You see, the ash, the organics do not want to mix in with the molten aluminum. Despite what NIST was telling us, he just couldn't get it to mix in. And the machinist working with us, he said, look, it's like oil and water. They just do not mix well. You can't expect organics. They float is what they do. They separate. And in this upper right, he added some glass, and finally we were ready to pour it out. And Mike, the guy that came to us from NIST, is pouring it. And you'll see what happens, what it looks like. Silvery. And he, of course, admitted, he said, with the naked eye also, it's silvery looking. And so he said, yeah, it does. And it looks silvery. He still has a job, yeah. Okay, so we observe that organics float to the surface. They produce embers when they're added in as wood chips. They do not produce the uniform orange glow that NIST said they could. And I put down here at the bottom, NIST is invited to show us how to make poured out liquid aluminum acquire an orange glow. We would like to know how they do this trick. No, but that's fair, right? If they make a statement, then they should tell us how to do this, right? And they should do some experiments. Gosh, they had $18 million or something in their budget for this. I think I'll skip these up. Okay, the last part. We're getting good. So let's see, 1:30. Whoa, am I supposed to be through at 4-ish? A little longer, maybe. Oh, because I started a little late. Okay, good. Thank you. Thank you. Whew. Okay, because there's still a lot to cover here. This is the most exciting part. This is the theory over here. So what else could it be then? We've ruled out molten steel. We've ruled out molten aluminum, even mixed with organics. We come to the possibility of highly exothermic, energy-releasing reactions, such as thermite, which is a mixture of aluminum powder. It's important to have it in powder form so you get this contact so the reaction will go. And iron oxide. Let me just say quickly, we poured some of that aluminum onto a rusty steel beam. We didn't have big exothermic reactions. Someone said you would. Well, we tried the experiment. Didn't happen. But no, if you go to aluminum powder, though, and iron oxide powder, mix those thoroughly. Now you'll get the thermite reaction. The end products are molten. The reaction zone itself is basically white hot. As the molten iron pours out, it's a yellow white hot, and as it goes for a while, it becomes, orange hot as it falls and cools. And then you also have, who knows what this white ash is coming off here? Aluminum oxide. So what's happening then is the oxygen is going from the iron to the aluminum. Aluminum wants it a lot more, and there's a huge energy release which results in molten iron. It's not molten steel, make that distinction. It's molten iron and aluminum oxide. Now that molten iron is hot enough to actually melt through steel now. This will cut through steel. Here's an example of that, and there's some sound here, but we'll go without the sound. So these guys, this is kind of fun. Over in UK, they've got some thermite. This is thermite. Add some thermite to the clay pot, and that has a hole in the bottom. They've probably got a piece of paper or something. It burns very quickly. We use the same trick, clay pot with thermite. They set it off, get a distance away. Don't do this at home. It's quite dangerous. Notice the color of the reaction region. Notice the aluminum oxide coming off. And then notice the flowing orange hot metal as it eats its way through the engine of this car. And if you look closely, you'll see it pouring out the bottom here. See right there? As it pours through the engine. And now they're going to look through and the camera below, and you see right through the engine. So this stuff is very powerful. And now they blow up the fuel tank, but we'll skip that. They made a point this is a Fiat car, and okay, so no loss, no loss. But okay, so moving right along. So again, here's a photograph or a still from the video. We have several videos of this molten metal coming out, several camera shots as well. Of course, eyewitnesses. There's no question about this, and it's discussed by NIST to their credit, and they, admit, okay, it has this orange glow. They think we can get it with flowing aluminum. We can't get that trick. So, and plus it has this white ash drifting away from this, and plus it had this reaction region before and then followed by the flowing metal. Folks, all of those characteristics point to compellingly thermite, unless we can find something out. Now, we're not done yet. When I say compelling, it's a pretty strong word in science. I think it is compelling, but we'll look at some more data and see how it goes. Here's, by the way, this molten material as it reaches street level, or close to it, was photographed. It's still glowing red. Aluminum has a hard time staying hot that distance. This is the South Tower, right? Thank you, Peter. Right. So here's, we actually did this experiment then at my university, and we cut through a steel cup with thermate. Now thermate is thermite with sulfur added. And in this case, we added a little potassium permanganate. I'll tell you why. But you can see the corrosion here that has occurred. And this steel cup isn't very thick. We're going to try thicker material soon now as we refine and work on our experiments, right, to test our hypothesis. We're not done just because of the similarities. We actually now perform experiments. High temperature corrosion is evident in this cup. I was working with a PhD materials scientist on this. I threw this slide in this week as someone pointed out to me. I looked at this before, but there are about 1,000 cars, there were, near the towers that were damaged, corroded in a very peculiar way. This corrosion on the top, and yet below the paint is intact. Some of them. Now, some of them evidently caught fire. Now, do you remember the guy putting the thermite on the car? and you remember the steel cup, the corrosion? When you put sulfur into thermite, it makes it so the steel melts at a much lower temperature. It's called forming a eutectic. So now instead of 1,500 degrees to melt the steel, you bring it down to about 600 degrees, which is easy now, right? Melt right through the steel. And plus you get sulfidation and oxidation if you've got an oxidizer in there, and you get this type of, you expect this type of pattern. Now, these are more data from the World Trade Center, which I'm saying is consistent with our experiments with thermate. Thermate is sulfur plus thermite. And the plastic has pockmarks in it, but it's not damaged like the steel was damaged. We had in our experiments some of these hot molten iron drops hitting plastic, and that's what they do. They put a little hole in it. And we actually had a little fire there in our experiments. If you get enough thermite on combustible materials, you'll cause a fire. All of that is consistent with what's observed here. This is just an aerial view. See the red building behind. These cars were near the WTC. I'm not positive. I think they're about here. And we still like to do more experiments. It would be great to get one of these cars, there are about 1,000 of them, and test the steel. Prediction, you will find some sulfur in that material there that's corroded in the steel. You'll find sulfidation. That is a very strong indicator of thermate. By the way, here's the towers. You see how they're reduced to rubble? And over here, building 7, just straight down, you know. And when you're done, it's this nice pile on its footprint. Amazingly. Seems like a controlled demolition to me. Okay, where were the World Trade Center samples obtained? We're going to talk now about the dust and the actual solidified metal samples. The dust was obtained from Jeanette McKinley's apartment, and she said I could use her name now that she sold her apartment. The chain of custody was directly from Jeanette to me, and it has been examined by me, and I've sent samples off to an independent laboratory for analysis. And also I work with colleagues in analyzing these materials. Now, the address is given there. By the way, USGS also obtained dust samples in this way. That is, apartments near the towers had the windows broken in. This is the case with Jeanette McKinley's apartment. The dust came in, settled, and Jeanette had she told me it was kind of almost a spiritual thing to save that dust for, she had that sense. I mean, you think about how many lives were lost. Now, this dust contains information, and so does the solidified metal. Solidified metal comes from Clarkson University, which is in New York State. There were 4 alumni from Clarkson who perished in the 9/11 disaster. Steel was sent to Clarkson to build this monument. A woman saw the steel. She saw that there was compacted dust and dirt inside the girder, this one steel girder. She realized this is going to be outdoors. The rain is just going to wash that away. And so she collected the dust in a plastic container. When my paper went out, these 2 women asked me if I'd like samples, the dust and whatever this stuff was. It turns out to be compacted dust and dirt on the steel. And so, of course, I said, yes, please send these samples. Now, from Clarkson, as we looked at this, my friend Dr. Farrer and I looked at this compacted materials, we sorted through that. There's all these pieces about the size of the end of your thumb, the end of your finger, and so on. These pieces of solidified metal, porous. Just what thermite residue looks like. Just a little more on that apartment building. Jeanette talked about it this morning. A little more on the Clarkson Memorial. They point out the steel, some of it was identified coming from the 55th floor of the South Tower. Okay, let's see. I'll come back to the this solidified metal here in a minute then. So, let's look at the characteristics. We've already talked about the white-hot reaction zone and the aluminum oxide that drifts away, which certainly appears very much and supports the hypothesis with actual comparative data. Thermite reactions may have occurred there. We look at photos of our experiment after this is now the residue, this is molten iron, quickly solidifying, still yellow and white hot. And at the towers after collapse, you see this material, this yellow white hot material. Reported also by Sarah Atlas, fires burned and molten metal flowed in the pile of ruins, still settling beneath her feet. That was published back in 2002. The actual report said molten steel because that's what she thought it was, I guess, this glowing stuff. But I changed that to metal so you wouldn't be confused. This would be, we think, well, let's see what happens when we analyze it. Here's a big chunk of this molten metal. No question it exists. This particular chunk is stored in a hangar at JFK, which we would like to analyze directly. Huge chunk of material with all this entrained rebar and concrete in with this. As eyewitnesses reported, pools of molten metal beneath both towers and Building 7, which wasn't hit by a plane. Therefore, it cannot be molten aluminum from a plane. Okay. Besides that, it's rusty. And aluminum doesn't give you red rust. It doesn't do that. Okay. Oh, this one you almost need to hear the audio. No? Okay. So here's this guy. That's too bad because here he's describing what's happening. Can we give it a try, do you think? Ken, can we try the audio or? No? Okay. Forget it. All right. You can go to my paper and it'll provide the link to this. He's saying this material they're pulling out is red hot weeks after. And he said, hold off on the water. They were spraying this with water, trying to get it to cool off. But these pools of molten metal stayed red hot for a long time. And as you pull out the material, you see this yellow and red hot material. It's amazing. Yeah. I haven't seen any good calculations on it. It's a lot. I mean, dozens of cubic yards, something. It's a lot of material. You saw the size of that chunk. And there's another photo, too, a comparable size. So, I mean, here's a photo. Some have denied that this existed, but we do have these photos. This is from the Lero group. And they talk about the red-hot debris, and this is published in their Lero News, this photo and the discussion of the red-hot debris. Okay, I'm just going to... So, a little more evidence then from the dust and the metal. Here we go. Now, I'm going to amplify what I said about the thermite reaction. Aluminum powder, but it doesn't just have to be iron oxide to provide the oxygen. You can use other metal oxides and oxidizers, such as zinc oxide, potassium permanganate, barium nitrate, and if you add sulfur, it'll cut through steel like a hot knife through butter. This molten metal. The other thing I want to emphasize, if you use finely divided aluminum powder and metal oxides, it gives you this molten stuff. And it's called an incendiary. On the other hand, if you use ultrafine nanoaluminum and ultrafine powders mixed together, then this material will explode. These are called super thermites, and so you can get both incendiaries, no sound particularly, and also with superfine you can get explosions. There could have been other explosives used in the towers, but as we see, there's evidence. The NIST fact sheet: was steel tested for explosives or thermite residues? Here they quote me. I like this. So we have a little dialogue now. The combination of thermite and sulfur, called thermate, slices through steel like a hot knife through butter. And that's what I said in at least one interview. I just said it a moment ago. I mean, I talk about this all the time. And they quote that. And so someone sent this question to NIST, and they respond. NIST did not test it for the residue of these compounds. They add a little qualifier in the steel. I would like to ask them what they mean. Did they test somewhere else? I would like to know. But we did. We did test for thermite residues. Here's our electron microprobe system, wave dispersive. Okay, here's what the residue from thermite looks like. Molten material with nodules that are nearly pure metal, pure iron in this case, as we're using iron oxide. This is from an experiment we did. On the left, you see material from the Clarkson Monument. And we also see the nodules and the porous metal there. So just the raw appearance already looks like thermite residue. Here's a big chunk of previously molten metal. We also looked at a chunk of that. So here we go now, looking at the electron microprobe data. The bright regions represent, in this case, iron. The dark regions mean less iron. And here we see aluminum, some aluminum, but not a lot. We can rule out clearly molten aluminum from the jet aircraft. That's just not what it is, folks. I don't know how many times we have to rule that one out, but it's ruled out. On the other hand, we see very little chromium. We see a lot of manganese, and again, a lot of iron. We'll quantify some of these in a minute. We see aluminum, potassium, and sulfur. If you look at certain regions, you get big peaks of sulfur. A lot of manganese, and also fluorine. I'm going to have to go through this kind of quick because my time is just drifting fast. Look, it's not molten steel because the steel has a lot of chromium and nickel, whereas the slag has very little chromium and nickel. On the other hand, the slag has a lot of manganese, aluminum, potassium, sulfur, even barium, whereas those metals and elements are reduced in the steel. Here's a picture of me this is the dust now with a magnet, and I'm just going over it and over it, pulling out the magnetic component. I was surprised at how much magnetic material there was in the dust, and I looked at that separately from the rest of the dust, and I found, well, among other things, this is a USGS photo. You see metallic iron particles. We also see metallic zinc. From the thermite reaction, you remember the sparks flying? Those are metallic iron, remember, because the oxygen's pulled away from the iron oxide. Now you've got metallic iron, molten, little sparks flying out. Those produce large pieces, yes, but they also produce small metallic zinc particles. It's a very hot reaction, so we expect small. We see these, again, consistent with thermite. Another instrument we use produced this data. This is a wave dispersive XRF. And here, this was a big surprise to me. This is normalized to the steel, and we're looking at zinc. And there was a great deal of zinc in both in the dust. These two are. This is the magnetic component of the dust. 200 times the amount of zinc as you have in the steel, and with the magnetic component out, 3,000 times. A lot of zinc. This I call the zinc anomaly. A possible correlation of zinc with iron would be interesting, because if you have zinc oxide and iron oxide in your thermite and you react those together, you then would expect metallic zinc and metallic iron, and those might sometimes come off together. So that's something that needs more study, but it's implied or at least suggested in these data. The zinc anomaly reported by USGS. I then went to their report, so I see all this zinc. USGS had previously reported about this dust. Remember now, this dust is telling us what happened. And it's a snapshot too, right? The tower collapses, the south tower breaks the windows of Jeanette McKinley's apartment, floods the apartment with dust. You know where the dust came from. It's thick, coating everything. She sweeps it up and puts it in a plastic bag and saves it and sends me some of this then. But this dust tells us what's going on. Now, the USGS did similarly. They collected dust samples, and they mention here that zinc is the predominant trace metal. There's also one sample with curiously high barium. Why zinc? I then went to Gibbs free energy curves for various oxides. Here's aluminum way down here. Without getting too technical, what you want is aluminum, which gets the oxygen. You want a metal oxide up here so that you get a lot of energy out of the reaction. Turns out that zinc oxide is right there, stable to high temperatures, to about 2300 Kelvin, which is 2000 centigrade, plus or minus. So aluminum plus zinc oxide would be a great choice for aluminothermics. Thermites. Okay, we're getting a little technical, but this is from the USGS report. And they mention high zinc. I realize this plot is kind of hard to read, so what I did is I pulled out zinc and so on and plotted it differently so you can see the data a little better. Okay, so here we've got titanium, zinc, barium, and manganese. This blue is the average of 12 samples. This is the USGS study now, published, right? And maroon is the maximum. So you can see there is variation in the samples, as Jen, I think it was, pointed out also. And the green is the concrete. This is, again, from Jeanette McKinley, an actual piece of the concrete that came through her window as the South Tower collapsed. And we've analyzed the concrete, and the titanium is explained. In other words, a lot of that dust was from the concrete being pulverized. And the titanium content is comparable, you see, from the concrete and in the dust. Titanium is explained. That's called a prosaic source for the titanium. On the other hand, the zinc is way high. This is anomalous. It's telling us something. Where does all this zinc come from? Look at that. This is the concrete down here. Do you see the green bar? It's enormously higher. Barium also much higher, and manganese. Now, gosh, barium nitrate is what the military puts in their thermate to make their grenades for destroying vehicles. Barium, that's explained, barium nitrate. And then zinc oxide, good choice as I went through the Gibbs free energy curves. And manganese. What's the oxide with manganese you want? Potassium permanganate, huh? There's another report. I pull out their data again. This is from Cortlandt Street, Corey Street, Market Street. Scientists studying the dust independently from us. Again, look at the zinc. In their samples, the zinc is higher than the titanium. Titanium is everywhere in the crust of the earth. Look at that. Look at that zinc anomaly. And again, manganese and barium are high. There's something, we can't just overlook these data. Now, as a scientist, this is kind of exciting. As a citizen, it's troubling. Can I just have a few more? Thanks. A consistent model of reality. So what we've got, is one model over here that we're taught that this was, 19 hijackers brought those planes down. And on the other hand, we're trying to build a model of reality by analyzing data, by analyzing the dust and the molten slag and looking at the material flowing out of the building. The collapse times of the buildings. We're trying to build up a model of reality by actually analyzing data. Now, as a scientist, I feel comfortable doing that. Even if I'm criticized, I've been through that before, With the cold fusion, we were proven right. That's a good thing. The important thing is we get at the truth. These criticisms, you know, nutcase, I've been called that, discredited, I don't know. You know, those don't mean anything to me. The science, experiments, that's what means something to me. Even being, I mean, you know, not laid off exactly, but retiring. Okay, that's okay. You know, it's okay. I want to know what's going on, and there's a reason. Ellen Mariani lost her husband there. She pled with me, find out the truth. Thanks. And we're doing this together, you know. So, okay, like Ben Franklin said back in about 1775, we must hang together or we will hang separately. Remember? Okay, so you're with me in this now, right? We're going to find out. Okay, thanks. And I'm following you. Okay. Thank you. So the picture of reality then is that aluminothermics are in evidence. And it does look like aluminum powder with oxygen-bearing compounds. This is what the data are telling us of iron, zinc, barium, and manganese with sulfur added. And there we go. An experiment then that we did in September, aluminum powder, iron oxide, sulfur, and potassium permanganate. We also now have some zinc oxide and barium nitrate. Barium's nasty stuff, so we add that to our thermite. I mean, whoever did this didn't seem to care about, you know, people. I'm sorry. But anyway, when we do the barium experiment with barium nitrate, like the military uses, you know, then we will have to do it somewhere out in the Tules somewhere. Anyway, so here's our data. We've got about 20 grams, which is less than 1 ounce of thermate. That's our mix. And on the left, we'll show you the experiment. On the left is an experiment with ordinary thermite. This is simply aluminum powder and iron oxide ignited with a magnesium ribbon. There it goes. There's the white flash. You see the dust, aluminum oxide drifting away. You see the molten, actually it's starting to get pretty solidified, but both in the clay pot and in the sand here, you see the molten residue. This is essentially iron, because that's what we had in the mix. There's some aluminum, but most of the aluminum goes away in the aluminum oxide powder, dust that drifts away. And this glows for a long time. You can see that. I'll let this video go on for a while, but it just glows and glows and just for a long period of time. Now the next experiment, it goes very quickly. This is in a clay pot, and this one finally is in a steel cup. Here we've added potassium permanganate and sulfur to the thermite. He's telling the guys, this is Phil Brown, he does these thermite demonstrations routinely. Don't touch this metal. Even if it looks cool, it's still very hot. And, you know, don't do this at home. So here, this goes real quick. Again, it's going to ignite. Boom. And notice the powder on this piece of equipment there. And there's the white aluminum oxide dust. And now here in a cup. This I didn't get much of. It goes very quickly. Just, yeah, that's very quick. This is the thermate eating through that steel cup that I showed earlier. And there's another picture of that steel cup. Cut through horizontally in a fraction of a second. As I say, we'll do more experiments. It's an invention, 1999, thermate-based apparatus for cutting target material of substantial thickness, linear cutting action. So, you know, these inventions do exist for using thermite to cut through steel of substantial thickness. Photo, I don't know, I won't talk too much about that except to say that this is standard now, explosive RDX, and typically you cut a column at an angle, And just there's a column from the WTC, which we're still studying. But it does seem to have this molten slag on this column. Inside, by the way, and outside the column. That's, you know. If you cut a steel with an oxyacetylene torch, this is what they use to clean up the steel at the ground zero, then you don't get a lot of slag typically. The oxyacetylene torch throws sparks everywhere. Besides that, the material that we've analyzed is not steel, remember? It has way too much manganese, not enough chromium, not enough nickel. Here's independent confirmation. This is very important to me. I have an independent lab. This is from Worcester Polytechnic Institute, published in a short paper, but also in Appendix C of FEMA. To their credit, they did publish this. And here's the photomicrograph, and here's the sulfur peak right here. So as you look in this metal, this is very strange. This is a sample from Building 7 and also a sample from the tower showed the same effect, sulfidation at high temperatures and oxidation. Evidence of a severe high temperature corrosion attack on the steel, including oxidation and sulfidation, with subsequent intergranular melting, readily visible. Severe corrosion and subsequent erosion of these two samples, Building 7, one, towers, the other one, are a very unusual event. No clear explanation for the source of the sulfur has been identified. Now, sulfur is used in thermate, right? We've talked about why, because it cuts through the steel faster. We've done experiments with it. It corrodes the steel. We will do further experiments and compare with their results, you see? Experiments we need to keep doing. So we're not quite done yet. But folks, it really looks like thermate was used on these buildings. There's just evidence just keeps coming in. I've been through this before, this sort of thing. We have an unusual hypothesis. It doesn't always happen that the data keeps, as you do experiments, it keeps adding to the veracity of the hypothesis. But that's what's happening here. That's why I feel confident to speak about this and to write about it and to say, look, it can't be ignored. Even if you don't like the implications, we still have to look at this. Here's a review. I'll skip that. I pointed out already some of these things. I do want to mention that thermite is used fairly commonly now in arson. Basically what we're talking, right, because it causes fires. And when you're done with an investigation of thermite in arson, you look at the solidified slag, you say, well, look, it's got manganese, and it's got sulfur, you know, these fingerprints for the particular thermite used. When you're done, you can say, yes, this was a thermite. Now you need to proceed with a criminal investigation. The fact that you established that thermite was used does not tell you how many people were involved setting the charges. It doesn't tell you where they set the charges. It doesn't tell you who set the charges, but it tells you there was a crime. You see what I'm saying? We then are at the point where we need an investigation of criminal proportions. The Guide for Fire and Explosion Investigations, the official guide used in the United States, unusual residues might remain from the initial fire. These residues could arise from thermite, also magnesium and other pyrotechnic materials. This is standard, and what we have to ask is, why was this not applied in the WTC investigation? It needs to be, or that's what we're doing, is applying it there. And we must insist then on a follow-up investigation. There's some other anomalies I will skip. I want to hit this because in the 9/11 community, I think it's very important that we not have a sense that we're just victims of this huge octopus. We can do certain things like building awareness, which is what we're doing today, sharing information. We still have the internet, thank goodness, and we have the ability to share DVDs, and the Journal of 9/11 Studies. We have our Constitution still. And there's some other things that we've talked about in groups, getting out of debt so that we aren't, in other words, reducing our dependence on the system. I'm talking a little freely, and you may not agree with me, but I think it's important to get money out of big banks and put it into local credit unions. We can all do that. We can work for what Carol calls a voluntary simplicity. She also talks about local currency. Out of credit card consumerism, food and water storage. My family's working on that, and I just bought 2 wood-burning stoves. You know, not expensive ones, but... And then we have these values. Instead of fear, we can build among ourselves, this cooperative, this sharing and caring and courage and being proactive as opposed to being victims. And that's all I have to say. Thank you. Thank you. Thank you very much.
Thank you very much, Dr. Jones. We are running a little behind schedule, but the next presenter, Jim Hoffman, said that that's not a problem because we want to let Stephen finish his arguments and his comments, and we also know that many of you may have some questions and like to talk to Stephen. So we will take a couple of questions right now, briefly, and then what's going to happen is right around here, to this way out the auditorium, there's a table with a whole series of free articles that have been run off, and some of Stephen's work is there as well as Jim Hoffman's. We're going to be starting Jim Hoffman's session at 3:45. That clock is wrong by an hour. So we're going to be starting Hoffman's session about 15 minutes later so that we're able to get a few questions now for Stephen Jones. And then please remember that Jim Hoffman will be talking about basically the similar or same topic coming up here. And also this evening's session, Stephen Jones will be in conversation with Peter Phillips of Project Censored, with Jim Hoffman, Paul Ray, Jeanette McKinley, and Jenna Orkin. So that's at 6:30. But let's take a couple of questions right now so we can get started here. We have, right here.
Oh, I was wondering if you are totally comfortable with the idea. The dust that came off from these explosions is finer than anything that's ever been recorded from what I've heard. And I was wondering, in addition to these the controlled demolition that brought down the towers, have you analyzed the cells of this dust to see if, well, I've heard of HARP technology, if there was any other type of technology in addition to that that was involved?
Okay, okay. First of all, the pulverization of the dust has been looked at by in Gordon Ross's paper. He talks about that a bit. See, as you can see, I'm looking for specific elements and metals. And the pulverization size, I don't have a great deal of comment. I remember Tom Cahill at UC Davis mentioned that the particulates coming off, this is now after a collapse, he's looking at those, were very small, abnormally shifted, in other words, towards the fine particulates. So there has been some observation of that. But that's a little different because that's after the collapse. I don't know of anyone who's looked at that from the dust from the collapse. It's certainly a good thing. Now, one thing I have done is I did send, I've asked an independent lab to look at the fine dust compared to the coarse material and compare the contents. So that's sort of addressing your question. But I realize from the second part of your question, there's more to it. You're talking about, as someone else asked me earlier, Dr. Wood says maybe there's a beam of laser or microwave from space or something that came down, and she says instead of thermites. Well, I'm saying, look, there's a lot of evidence for thermite, And on the other hand, some exotic laser or maser beam, I'm one that's open to suggestion, but boy, there better be some pretty good evidence, you know. And I haven't, it looks to me like the thermite explanation fits the data quite well, and so that's where I stand on that. But plus the fact that it takes a lot of energy. If you're sending a beam of laser from space, you've got to have an enormous energy source in space to do that. And that's been looked at. It's tough. It's a tough problem. It's almost ruled out there. I don't think we have such a weapon, thank goodness.
We have another question up here, and then we'll come back down there.
Hi. I noticed when you described the situation with the World Trade Center, you talk of 3 buildings, building 1 and 2. I've got a German site that I looked at, and it says that at the same time that the building 2 fell, there was an explosion in building 6, which blew out the center 8 floors. Also, the next day, WTC-3, the Marriott Hotel, exploded in the same manner. So I thought that in relation to your talk, it would be good to not just limit it to just those 3 buildings, but to realize that this looks like a whole plan for the whole center. And okay.
You know, building 6, you're right, is very curious. As you look at the aerial photograph, which I could go back to, there's a big hole in the center of building 6. And there needs to be more study on that. I agree with you there. Until that study is done, I don't, you know, in other words, we have the right to reserve judgment. That's the same thing I do with the Pentagon, would hit the Pentagon. Until we get more data, I'm reserving judgment. I don't think it was a missile, by the way, personally, from the data I have seen that hit the Pentagon. I do want to see data. I'm just a guy that likes hard evidence whenever I can get it, you know. Video evidence, if, you know.
Okay. So we'll take a couple more questions.
Oh, he's doing the mic. Are you doing the mic? Okay. Okay, that's fine.
Dr. Wood's investigation also reveals that much of the towers became dust, not just the concrete but the steel. And thermite cuts through steel. It doesn't explode and turn steel and concrete to dust. She did that using the seismic evidence. How would you explain that?
Well, now, let's look at the data again. You're saying that much of the steel turned to what was evaporated. Can you give me evidence for that? I don't know of the evidence. In fact, I don't believe. The seismic signal will not tell you. Yeah. Well, that doesn't mean that the steel was turned to dust. I mean. The steel itself was oh. Now that's an interesting statement, but it needs to be demonstrated to me. I mean, you can't just say that. In other words.
Okay.
I've looked at her site.
We have another question here, so you can carry on your conversation with Dr. Jones after the session, and you can debate with him at that point.
I do have one quickie, though, on that. She also talks at her site about, look, the calculations need to be done more. But the other thing is the cars, which I talked about, those look very much like thermite for the reasons I explained. She says that's a laser beam hitting things, or a maser. But no, that would not account for the pockmarks in the plastic and the corrosion in the steel like thermite does. So really, I think that already the thermite explanation is much better. Plus, she needs an energy source for her high-energy weapon and some place where it exists. I'm sorry, we need more data to support that. And the same thing with no planes hitting the towers, which Judy Wood supports. I do not support that because there's great evidence, including the swaying of the second tower, the south tower, as it was hit, and the debris. You see, I mean, there's all these evidences. I'm sorry, I find myself in disagreement with Judy Wood on those points, for the reasons mentioned.
Yeah. Thank you.
Hi, my name is Deborah Yanez, and my brother-in-law was stationed to go to to New York to help in the cover-up. And he's a Moose Freemason who also was wanting to go to Iraq to kill the people there. And after they took him there, he was shipped off to Iraq to help in the medic team, but he ended up using weapons to help kill the people. And I was wondering if any of you people have like relatives who belong to the Freemasons, and people are in the cover-up or people in the military that who have now looked at all these things and realized that, you know, there's a lot of blinders, and if there's any type of police group that are being outspoken about these things and trying to come forward on some of the evidence that they've found themselves and help cover up.
That's basically a request, which, let me just say, I'll just put this here, you can read it. There are many anomalies related to 9/11 that need to be pursued. Thank you.
We had time for one more question here.
Professor Jones, would you say that the energy released by thermite and possible cutting charges would be enough to cause large structural members to be flung as far as 300 or 400 feet away from the building? And if not, then what would account for that?
Well, explosives would. Remember super thermites, the finely powdered form of the thermite, is explosive. It's very high energy density, and it is explosive. And one of the reports I saw said it compares favorably with the conventional monomolecular explosives. This is not monomolecular, obviously, but when it's finely powdered, it will explode and do the same effect, hurling these beams horizontally, which, by the way, is very important evidence for explosives.
Unfortunately, we're running over schedule right now, so we have to limit some of the questions. However, Jim Hoffman's session is going to be beginning within the next 10 minutes or so. If you'd like to speak with Stephen Jones, you can feel free to do that. Remember also that Dr. Jones will be speaking at the 6:30 session this evening in conversation with several people, and there will be a longer period of question and answer available at that time. And also, I understood that Jim Hoffman said to me a little bit ago that if Stephen wants to join him on some of his questions at the end of Jim Hoffman's session, then you can stick around and ask more questions at that time. But at this point, we're behind schedule, so we're going to try to start Jim Hoffman in the next 10 minutes. Thanks again for being here, and hope to see you in a couple minutes.